Nice, thank you. Okay, hello then again. Thank you so much for having me, and once more, thank you for rescheduling my presentation. Well, my name is Aggelos Tsaligopoulos. I am a postdoc researcher in the Department of Environment in the University of the Aegean in Lesbos Island in Greece. Today, I would like to present to you our research entitled Circularity-driven urban quietness as an indicator of sustainability. Well, as you know, there are multiple ways to communicate noise and quietness. These terms present a polysemy. They are multidimensional, as they can be described through physical, perceptual, legislative, biological, and even through an economic lens. Well, these concepts are also contradictive, as it is very hard to describe quietness without even implying noise. So there is a contradiction, and if noise is unwanted, then the state of quietness is desirable, and so forth. There is even a socioeconomic contradiction between these two terms. So if noise is considered an oppression, then quietness is considered a privilege, and so there's issues of gentrification and social inequalities involved in noise. Back in 2016, along with the Hellenic Society for Acoustic Ecology, we organized a conference in the University of the Aegean in Mytilene entitled Sound, Noise, Environment. The goal of this conference was to utilize the interdisciplinarity of acoustic ecology and discuss the different views regarding noise through ecology, music, social sciences, arts. Interestingly enough, we highlighted that the way we conceive noise can affect our understanding of quietness and therefore initiate the way we deal with noise and the approach of the creation of a quiet and healthy soundscape. The two approaches that deal with noise differently is the soundscape approach and the traditional noise control approach. Both approaches have benefits, but in some cases, of course, not in all cases, ecological co-benefits are being overlooked. Sometimes there is a sacrifice of long-term ecological benefits in order to enjoy short-term benefits. So through this research, we tried to promote the long-term ecological co-benefits of quietness, moving away from the traditional definitions of quietness that homogenize all sounds under the intensity and promote additional concepts similar to acoustic complexity. To this end, we produced a new definition of urban quietness, which regards a balanced public acoustic environment where complex sounds prevail, regardless of intensity and source, created or preserved in the context of environmental sustainability and environmental equity. Here we hypothesize that sound complexity can be a vital component of a healthy acoustic environment. I would like to quickly talk about the importance of complexity through the disciplines of ecology, urban design, and soundscapes. As you can see in this graph that regards the number of publications that deal with complexity, there is a steady increasing trend regarding the number of publications from 2000 to 2022. Ecology stands as the discipline that deals the most with complexity so far. So there might be variations regarding the way that complexity is being conceived and described and used through these disciplines. But also there are similarities, especially regarding the field of ecoacoustics with the use of the acoustic complexity indicator. Overall, complexity can be understood as a fabric of heterogeneous but associated elements. Another thing that is common is the scale of complexity, beginning from simplicity to complexity, then to chaos, finally to complication that results in a homogenization that closes the loop as it resembles simplicity. Therefore, we believe that unsustainable development and excessive noise can lead to homogeneity or simplicity, which is a downgrade of the urban environment. So our goal as a research team is to promote environmental co-benefits and highlight methods that promote the symbiotic relationship between quietness, sound complexity, and environmental sustainability in an urban environment. Regarding the concept of circular economy, as you probably already know, this model could aid the successful transition towards sustainability. This model moves away from the traditional linear model of take, make, waste, and suggests a circular model that focuses on resource looping, amongst other things. And now I would like to present 2 case studies regarding Mediterranean waterfront soundscapes. The first one regards the city of Mytilene in Lesbos Island in North Aegean in Greece, where we simulated on whether circular economy actions benefit the acoustic environment of a city. The second case study regards an empirical study conducted in the city of Thessaloniki and highlighted the effects of road traffic noise. Actually, right now I am in Thessaloniki. It is my hometown. Well, more specifically regarding the first case study, regarding Mytilene, we simulated the effects of green walls and electric vehicles using correction coefficients provided by literature. And for the second case study that regards the waterfront of Thessaloniki, we assessed the acoustic conditions during the lockdown period of 2021 and conducted comparisons with 2022 in the post-lockdown period. Both cases are waterfronts with high health restorative properties. Both are highly visited public spaces. They are of roughly the same size and are both affected by a major road. As you can see here in Thessaloniki, this is the major road that affects the waterfront, and this is the sea, the Thermaic Gulf. And in the case of Mytilene, this is the major road that affects the waterfront with the sea down below. Regarding the methods, there were common methods in both case studies. The common methodological approach regarded the detailed mapping or the cartographical representation of the built environment. So data regarding building height and vegetation height, the type of road, and even the location and operation of traffic lights were gathered and used. Furthermore, amongst the common methods are all noise measurements that were conducted using a calibrated sound level meter, using short time measurements, in order to extract noise indicators similar to LEQ. Furthermore, we conducted sound recordings that were done simultaneously with the noise level measurements using the same protocol, of course. We used the R statistics software and the associated R packages in order to extract acoustic complexity indicators. Additionally, we used the guidelines provided by the CNOSSOS-EU road traffic noise model that includes the counting and the categorization of vehicles in using 4 categories. This includes the light vehicles, the medium heavy vehicles, trucks, and 2-wheelers. For the noise mapping, we used the CADNA-A noise prediction software, with roads being the main source of noise. Furthermore, with the use of the QGIS software, we visualized the acoustic complexity levels using an interpolation technique. Now for the first case study that included the simulation of green walls and electromobility. We followed 3 steps. Firstly, we assessed the current condition of the area using the guidelines of CNOSSOS model and conducted noise level measurements for validation reasons. Secondly, through the noise mapping software, we applied correction coefficients for the sound absorption of the building walls. And also we introduced noise reductions for the light vehicles counted. Finally, we compared the results. I'm certain that you already know the benefits, the co-benefits actually of green walls and roofs. So green walls can increase biodiversity, they can accumulate pollutants, air pollution, they improve the microclimates and also have sound insulating and sound absorption properties. According to global literature, the absorption coefficient of green walls is about 0.4 degrees. For regarding electromobility, the electric vehicles, we used the guidelines that were provided by the CNOSSOS model. That has provided correction coefficients for electric vehicles corresponding to specific frequencies. So we incorporated these corrections and reductions in our noise mapping software by altering the noise levels produced from light vehicles. So to this point, I would like to stress out that the life cycle assessment of electric vehicles highlights problems regarding the resources used to manufacture them, and also in the end of life procedure. So as a product, electric vehicles are clean and quiet, but there are still many things that need to be fixed in order to be considered truly sustainable. Now for the results of the first case study, the simulation indicated statistical differences between the overall noise levels after the simulation of the circular economy applications. There is a difference of about 4 decibels, which is close to the results that can be found in literature in similar studies. Nevertheless, as expected, this 4 decibel reduction is hard to see in the noise maps created. Now for the second case study regarding the waterfront of Thessaloniki, we utilized the unfortunate event of the lockdowns that were implemented during the pandemic. Well, the goal was to go beyond simulation at this point and test the effects of road traffic noise in real condition or the absence of road traffic. So we conducted noise measurements and sound recordings during the day period for a week during the lockdown of April 2021. And then we repeated the same protocol during April 2022. The main concern was the major road that is parallel to the waterfront under study. This time, the statistical differences were greater, and a difference of about 13 decibel between the lockdown and the post-lockdown periods are highlighted. So this 13 decibel difference is obvious in the noise maps created, but this was expected. What is interesting, though, is that we detected elevated levels of acoustic complexity during the lockdown period. As you can see in this map, this part here, the variations of the acoustic complexity levels are greater. And here is the acoustic complexity map during the post-lockdown period of 2022. This indicates a homogenization and therefore a simplicity of the area's acoustic environment, which was imposed by the increased road traffic. So I'm about to finish now, very fast, regarding the conclusions. We highlighted 4 decibel reduction with the implementation of circular economy applications and 13 decibel reductions with limited traffic conditions due to the pandemic. Nevertheless, in none of the cases, the 55 decibel threshold suggested by the World Health Organization was not met. So in conclusion, we see that the implementation of circular economy actions could actually benefit the acoustic environment. It could result to decreased noise levels, but unfortunately, the benefits of our absence, or at least of the absence of the vehicles as a result of the lockdown, is unmatched. Overall, the way that we conceive noise can affect our understanding of quietness and therefore indicate the way that we deal with the noise problem. Therefore, the focus should be on creating a soundscape that is diverse, interesting, and complex, rather than simply attempting to eliminate noise or unpleasantness in a broader sense. So we propose local smart solutions that promote long-term sustainability co-benefits and incorporate the interdisciplinarity of acoustic ecology. Finally, I would like to show you a glimpse of our future work as it is still in its very early stages. This regards the second case study area in the waterfront of Thessaloniki. In this waterfront, there used to be an artificial waterfall. This waterfront was used in order to mask road traffic sounds. Unfortunately, this waterfall is out of order for more than 10 years now. It was too expensive to maintain it, and there were other reasons as well. So I'm sorry for my dog. So in the spirit of smart cities and the Internet of Things technology, we propose a connection of the waterfall's water flow and the time of its operation according to the noise levels produced by the major road. So our future research will regard the planning of such a solution and also the investigation on how the waterfall affects the acoustic complexity of the area. That is it for me. Thank you very much for your attention.